everyone, welcome to the channel. My name's Nader. In this video, we're going to go over a bunch of exercises for the async await syntax in JavaScript together. We went over async await in the previous video together where we learned about how this helps us work with promises in kind of a more synchronous fashion, so kind of a more top-down fashion. This video is just going to go through a bunch more exercises for more practice with that concept. So let's get right into the exercises together. Okay, so as with all the other exercise videos, I've created a kind of bunch of comments at the top of each of these files. I have a warm-up as well as 3 exercises ready to go. I'm going to kind of go through all these comments and then we'll talk it out a little bit together. I'll give you a chance to try it out yourself and then we'll actually go through a solution, or at least one possible solution, with me coding it together. So for this warm-up exercise, we want to create a function called fetch Pokemon that returns a promise that resolves with the value of kind of this object right here after 2 seconds. Okay, so this is kind of a delayed response where we get back this object within a promise after 2 seconds. So we can probably use a set timeout for this. You can tell I really love Pokemon. This is actually kind of a precursor to future videos where we're actually going to be building a lot more things with a kind of Pokemon related things and an API and things like that. So this is going to give us some great practice. Then I want you to print out program starting right away, kind of below this function declaration. Then I want you to create an async function that uses await to wait for the data to come back from our fetch Pokemon function that we just declared above. And then we want to log out the data once it comes back after that 2 seconds. Okay, then we want to call that async function so we can actually execute the function body, and we want to log out program complete. Okay, and this program complete is going to be in the outer scope, so we should actually see it logged out much before a lot of these other things. Once you're done kind of these above steps, I'd like you to kind of redo the steps, but with a small change, right? So instead of resolving the promise here with this value, I would like you to reject the promise that comes back from fetch Pokemon with an error object that has a message danger, danger, okay? So this is going to require you to actually modify your async function here in step 3, where you're calling and using that fetch Pokemon in an await using a try-catch block. Okay, so I'll give you a chance to try that yourself, and then we'll go through the solution together. All right, so to start, let's start with step 1. Create a function called fetch Pokemon. Okay, so I'm going to go with arrow functions as usual here. I'm going to say const fetch Pokemon. And this looks to be a regular function. I didn't really say anything about this being an async function. And we want to return a promise that resolves with some object after 2 seconds. Okay, so let's first try to figure out how we kind of make a promise. So we're going to kind of return a new promise here. And we know that promise takes a resolve and a reject. We saw this in the promises video together. And what we want to do is we want to resolve with this object, but after 2 seconds. Okay, so we can resolve with, I'm just going to copy this so you don't have to watch me type it out, with this object, but we want to do this after 2 seconds. So in order to do that, we need to wrap this code in a set timeout. This is how we've been kind of delaying our responses. In the future, when we actually kind of get to a bit more kind of advanced use cases for how async kind of works in the real world, for example, this is not going to be kind of a set timeout. It'll probably be something like going out to a database or going out to the file system or something that's going to take some amount of time. But set timeout is an excellent kind of simulation of how that's going to work. Okay, so from the outside of this promise, there's actually absolutely no difference between doing a set timeout and doing kind of going over a network or going over to the disk, for example. All right, so inside here, we're just going to create a function, and we're going to say that this is going to take 2,000 milliseconds, and I'm just going to move my resolve inside of there. Okay, so we're saying that this promise is going to resolve with this object, but after 2,000 milliseconds or 2 seconds. And we're not going to use reject right now. We're going to use that later. And you can see that we're returning this promise object from this function. So when we call this function, we're going to get back this promise object. Okay, then we want to log out program starting. So I'm going to console.log and I'll just copy this so I don't have to type it out. Then we want to, and this is where the async await comes in, want to create an async function that uses await to wait for the data to come back from our fetch Pokemon function and then log out that data, right? This data right here. So let's go ahead and do that. So we're going to, let's call this const, let's just call it like use Pokemon, for example. You could have used any name. I'm just going to go with whatever comes to my mind. But in this case, this is a regular function right here. So we wanted this to be an async function. So let's tag it with async. And now kind of this gives our function quote unquote superpowers per se, where we can actually use the await keyword inside of here, and it does a couple other things to our function as well behind the scenes. So now what we can do in here is wait for the response from fetch Pokemon. Okay, so I'm going to say const data is equal to calling our fetch Pokemon function, but this is going to take, in this case, some amount of time. And we know how much time because we hard coded it to be 2 seconds. So instead of using a .then, what we can do is do an await, right? So the function is going to pause on line 31. It's going to wait for that object to come back, put that inside of data, or technically point data at that object, and then we can actually console.log this data. So we don't actually run line 32 until 2 seconds after line 31. Okay. And then finally at the end here, we want to console.log out program complete. I actually missed step 4. So before we do this, we actually want to call this function because we actually only declared the use Pokemon function. We actually haven't executed any of this code inside here yet. So to do that, we want to call use Pokemon in this case. Okay, so we're declaring our function, returns a promise. We're going to log this out. We're declaring another async function. We're calling that async function, and then we're going to do another log. So before I actually run this, if you haven't already kind of done this yourself, I'd like you to think about what the order of these logs is going to be. So let's go ahead and make sure we're in the right folder here. And I'm going to use Node to run the warm-up exercise. And let's take a look here. Okay, so we get program starting, program complete right away, and then we get our data object being logged out. Okay, so hopefully that's kind of what you guessed. This was definitely quite tricky, and the more that you work with async functions and promises, the easier it'll be to kind of spot how this works. So this is happening because we're declaring a function that doesn't do anything. Immediately we're doing a console log. So this is going to logged out right away because our code is going to run line 28. We're declaring another function. Nothing happens when we declare a function. We don't actually run any code yet. Then we're actually executing use Pokemon. So we're actually going to call that function that we declared on line 30, but the first thing this function is going to do is just kind of pause itself and wait for a promise to resolve, which is going to take 2 seconds. So then we have a chance to run synchronous code outside of this async function, which is why we see line 36 being logged right here. And then 2 seconds later, once that promise resolves, since the program has nothing else to do that's synchronous, it actually logs out that object on line 32. All right, so hopefully that kind of makes sense. Let's kind of look at the steps 6 and 7 here real quick. So we want to actually now reject this promise and see what happens as a result of that. So I'm just going to comment out this resolve, and I'm going to say a rejection here, which is this second argument that we get passed, which is the rejection function. And we want to give it a new error object with the message of danger, right? Danger, Will Robinson. So what's going to happen here, right? This is obviously not going to resolve now because we have no resolve, right? So our set timeout is going to wait 2 seconds and it's going to immediately reject this with an error object. So this promise has no chance of ever resolving. So if we run this right now, let's see what happens. So we get our program starting and our program complete, but then we kind of get this error object being logged out right here, which is danger, which is our error. So this is actually not good because what we're kind of doing in this case is not actually catching this error, right? You can see that we're really not doing anything with data here. We don't have access to data. In fact, if I have a console log here and I do something like done fetching right here, and I try to rerun this code, you'll see that we never ever get a chance to get to the done fetching code, which is on line 34 or line 33, because our program just straight up crashes on line 32. Okay, and it's crashing with this error right here. So this is technically an unhandled promise rejection error. So we saw in the previous video when we looked at async await that regular vanilla promises allow us to use a .catch block, but we have to use a try catch block in the async await syntax, which is very similar to other error handling in JavaScript in general. So if we surround this with a try, because we know that this code in here might cause an error, we want to do a catch here, and I'll say the error that we're going to get, and I'll do a console.error with the error object, and I'll also just log out here just to prove to you that this actually continues executing the code. I'll actually do this outside the catch, sorry. I'll say there was an error with our code. Okay. Actually, in this case, I should probably log out something. I'll say like, but we're okay. Okay. Like we kind of caught this error and we can continue running our code. So let's see what happens here. So program starting, program complete. And then you can see we get danger being logged out, which is actually happening on line 37 in this case, because we're catching that error and then we're console erroring it out, which actually allows us to see kind of this like stack trace and a few other things in there. And then we're actually seeing this message, which is outside of that block. There was an error with our code, but we're okay, right? So our code does successfully continue executing even though we had an error in our program. What we don't see though is these two things, right? Because as soon as there's an error, we immediately jump to the catch block. And in this case, the error is happening right here, which is on line 33. So we skip over line 34 and 35 in my case. We jump straight to line 36 and 37, and then to line 39. Okay, so definitely quite a lot going on here. Definitely make sure you feel comfortable with this. Maybe rewatch it a few times, try to rejig a few of the variables around and the timings and things like that. Really, really important exercise to kind of get started with async await. All right, let's go to the first exercise. So for this one, we want to create a function called fetch user that returns a promise that resolves with this value. So very similar to our fetch Pokemon, except this is going to take 3 seconds instead of 2, and the data is slightly different. Okay, so most notably, it has a data property, which itself is an object with a user and admin property. Then step 2, we want to create a function called login that takes an object as its argument. Okay. And this function is going to check if that object that's being passed to it as an argument has a property called admin with a value of true. Then we want to log out successfully logged in if that's the case. And if that's not the case, then we want to log out failed to log in, please try again. So this is some kind of like admin simulation function. Okay, quite common actually as we start building web applications. So next is step 3, print out program starting. Step 4, we want to create an asynchronous function that uses await to wait for the data to come back from our fetch user that we created in step 1. So this user object kind of right here. And then we want to pass the result of calling fetch user, which is that user object, to our login function that we created in step 2. Okay, and we kind of want to see what happens. And then we want to call that async function that we created in step 4 to make sure all the body runs and then log out program complete, just like we did in our warm-up exercise. So a few more steps here, definitely a bit more involved. I'd like you to give it a shot yourself, and then we'll take a look at it together. All right, so let's go step by step here. So step 1, create a function called fetch user. All right, so I don't see anything about a async function, so I'll just say fetch user, and this is going to be a function. This function is going to return a promise. Okay, so we're going to return a new promise, just like we saw before. This is going to take a resolve, a reject, and now we have a promise. All right, so we want to resolve with this value after 3 seconds. Okay, so I'm going to create a set timeout in here. And in here, I'm going to pass it a function. And I'm going to say this is going to take 3000 milliseconds. And I want to call our resolve function and give it that object to be resolved with after 3000 milliseconds. Okay, so that is all of step 1. right? So we are actually returning this promise object, and then we can do a dot then, or we can use an await to await the result of that, which is going to take 3 seconds. Now for step 2. So now we want to create a function called login that takes an object as an argument. So again, nothing about asynchronous functions. So I'm just going to create a regular function, const login, and then it is a function. There we go. It takes an object as an argument. Okay, so I'm just going to say that this takes an object. I don't really know what that object is right now. I don't really like this parameter name because it's too generic, but we'll fix it in a second. If the object has a property called admin with a value of true, then log out successfully logged in. Otherwise, log out the failed to log in, please try again message. So it looks like this is probably some kind of user object. So I'm actually going to rename this to user just so it's a bit more clear what's actually happening. So we want to say, does this user have a property of admin? Okay, so we're asking, is this property on there and is it true? Okay, so let's see. So we're going to say if the user object, right, dot admin, right, so we're going to access the admin property, is equal to true. Okay. Now there's a short form for this, which we'll look at kind of as we do more of this, but I just want to make this very explicit to start. So if user.admin is true, so this is triple equals true, right? Then we want to print out this message right here, successfully logged in. Okay, so I'm going to console.log, successfully logged in. I know I'm kind of scraping the bottom of my screen here, trying to keep the instructions here for us as well. And if it's not true, then we want to do fail to log in, please try again. So I'm going to put an else here. I'll say else, fail to log in, oops, console.log, fail to log in, please try again. Okay, so if we don't have admin being true, then we'll see this. Otherwise, we'll see that we're actually able to log in because we're an administrator. Nice. So now we have step 4. Here's where the async function comes in. We want to create an async function that uses a way to wait for the data to come back from our fetch user function. Okay, let's say that, let's call this const. I'm just going to go with kind of the use theme. I'm so used to doing this from React, where it means something totally different, but we'll just go with this for now. So let's just say const use admin, okay? And this has to be an asynchronous function. So we need to tag this with async. This was not an async function. This is a regular arrow function. Same with this, not an async function, regular arrow function. Okay, this is an async function. We're going to upgrade it. We have some superpowers, and now we can do await in there, and it returns promises by default as well. And then we want to wait for the data to come back from fetch user, and then we want to step 5 pass the user to the fetch that we get from fetch user to the login. So let's do step 4 first. So we're going to say, let me scroll down a tiny bit just so we can see a little bit more. We'll say const user is equal to. So we're going to do fetch user. This is going to take 3 seconds. We're going to get back a promise. Okay, so now in an async function, we can do await. And this is only possible because fetch user returns a promise. We cannot await something that doesn't have a promise. But after this, so if we get to line 41, we can be sure that we caught the user successfully. So user is going to exist in some form after we get to line 41 because we've already awaited it before. So the function is going to pause on line 40, and then we're going to get access to user on line 41. So we want to pass that user to the login function. Okay, so let's try that. So we're going to call our login function, and we're going to give it the user object. And this is going to work because we have user again after we wait for 3 seconds here. So we're going to have that correct object for us. Then we want to call this async function and then log out program complete. So we're going to call useAdmin, then we're going to console.log. Just copy and paste this, program complete. All right. So I'll just pull up my terminal here. And before I run this, same thing as last time, right? A lot going on here. Very, very challenging one. I'd love you to try to actually trace this code on paper, in your mind if you want, what's going to get logged out and in what order. And then I'm going to run this. Okay, so we're going to run node. This is exercise 1 and moment of truth, program complete. we're going to see fail to log in, please try again. Okay, so why is this? I actually am not really sure why this is. I actually expect this to be failed to log in. So let's just do some quick debugging on the spot. I expect to see this message, right? So I want to see if the user.admin property is true. And I actually kind of already see what the issue is. And you probably are like, oh my gosh, Sandra, you should fix this. What are you doing? But let's kind of take a look at this. This is how I would debug this kind of in real life, okay? So I would like to console.log out my user object right here. Okay, and I want to see if I can access the admin property on this. Does this have admin on it? That's my question. So let's take a look. So we were going to wait 3 seconds and we're going to get back our user object. There it is. Okay. And if you look really closely, what you'll see is that this doesn't really have an admin property on it. This has a data property on it, right? But that data object has an admin property on it. All right. So I can kind of fix this in 2 ways. I can either pass in the data directly to user, or I can kind of try to actually get the data property out of here. So I can do user.data.admin, for example. I don't think that makes as much sense because a lot of APIs or servers or things like that return something that might look like this, where they give us a data or they give us errors, and we want to really just pass the data to our login. So in this case, the user object really is the user dot data. So technically a better way to think about this is the result object, right? And then the result, can't copy and paste fast enough here. The result dot data is actually the user, if you think about it, right? So data is this entire thing, but user is just this object right here, which has a user property and an admin property. Technically, a better name might be name and then admin. So let's see if this works. Just going to run this. I, fingers crossed, hope to see successfully logged in. And there we go. All right. I would have been a bit scared if I didn't see it there. I probably would have been a bit confused with JavaScript. So luckily, JavaScript always does the right thing in this case, and it does match our mental model for this program. So hopefully that makes sense. Definitely trace this code. There's definitely a lot going on here with our 3 different functions. This is kind of getting closer to what we would see kind of when we really program with asynchronous code in JavaScript. Let's go to exercise 2. All right, so for this one, we want to create a function called fetchFast that returns a promise that resolves with the string fast done after 2 seconds. Okay. Then we want to create a function called fetchSlow that returns a promise that resolves with the string slow done after 6 seconds. You can just see how creative I am, right? We want to print out program starting right after this. And then we want to create an async function that uses await to wait for the data to come back from fetchFast and then log out the data. Then we want to use another await to wait for the data to come back from fetchSlow and then log out the data as well. All right. Then I want to call that async function that we created, which is this one right here in step 4, and log out program complete. So the questions we have here, right? Definitely a bit more open-ended. How long is this function, right? This one right here in step 4, how long is that going to take to run with the way that we have it set up? And the next question is, how would you be able to speed up this function? Okay. And I think I should probably add that when you're trying to speed this up, assume that these 2 things are totally independent of each other. So we don't actually need to wait for one to complete before we can actually start trying to ask for the other one. We can do them in parallel. All right. So give that a shot yourself. Definitely more challenging and open-ended, and then we'll go through a possible solution together. Okay. Perfect. So let's go ahead and create these 2 functions, fetchFast and fetchSlow. So we're going to say const fetchFast, and this is going to be a regular function. This is going to return a new promise, and it's going to resolve, and it's going to reject. And then we are going to take 2 seconds for this one to resolve with the string fast done. Okay, so I'm just going to copy that string. I'm going to do a set timeout, and I'm going to say, please do this after 2 seconds, 2000 milliseconds, and I want to resolve with this string. All right. Then we want to create another function that's called fetch slow that returns a promise or resolves with the string slowdown after 6 seconds. Now, I'm really not a fan of copying and pasting code, but in this case, I'm just going to do this to speed up the video because it's literally the exact same thing, just with a slightly different kind of speed to it. So I'm going to change this name to fetch slow, and I'm going to change this to slowdown, and I'm going to change the timeout to be 6 seconds instead. In the kind of previous video that we saw actually how we can kind of pass in parameters to actually kind of change the set timeout to be whatever amount of time we want, but just to kind of keep it very explicit, I think it makes sense to have two separate functions here. Okay, so this is going to take 2 seconds. This is going to take 6 seconds. I'm just going to minimize these just to save myself some space on the screen because that code hopefully is not too much based on the other ones that we saw so far. Then we want to console.log program starting. So I'm going to do this right here. Now comes the interesting part. We want to create an async function that uses await to wait for data to come back from these. So I'm going to say const, let's just call it like use data. Go with my theme of use here. I'm probably going to get myself in trouble with React for that in the future, but it's okay. And in this function, now we can use await to wait for the data to come back from fetch fast and then wait for the data to come back from fetch slow. Now I purposely put it in this order so that you can kind of get a sense for, maybe there's some other ways that we can kind of speed this up. But let's take a look. So we're going to say const fast result is equal to await fetch fast. Okay, and then we're going to say console.log out the fast result. And then we're going to say const fetch or fast, slow result. My gosh, fetch slow fast. So much stuff going on. Await. This is our fetch slow. Okay, and then we want to console.log out our slow result. All right. So that is step 4 right here. Okay, we're going out to do the fast fetch, waiting for it. Then we're going out to do the slow fetch, waiting for it. And after each of those, we're actually logging out the result that we get. So we want to actually call our function here. So we're going to call use data. Then we want to log out program complete. Okay. Now, let's take a look at this together really quick before we actually run this code. So this is going to take 2 seconds, and this is going to take 6 seconds. Oops, put it in the wrong spot. This is going to take 6 seconds. Okay, so that said, kind of how long is this code going to take to run? And try to think about this without even running the code. Okay, and I'll show you how we can actually time this in a second as well. But it's really important to try to make sure that kind of your hypothesis or what you're guessing eventually becomes closer and closer to the truth so that you can prove to yourself that you actually understand what's happening with the code. So we have some function declarations here. We're not running any code. Then we're going to see this logged out. Okay, another function declaration, we can ignore it. But now we're actually calling that function. So we have to come back here. We're going to execute line 41. Okay, that's going to take some time. We're going to see the result. Then we're going to execute. Then we're going to actually execute fetch slow. I actually missed a step here. While we're waiting for this, technically what we're going to do is pause the function, and we're actually going to see program complete because we actually run synchronous code while the asynchronous code is kind of churning in the background and is being scheduled. So we're actually going to see program complete. Then we're going to do fetch fast, or fast result is going to come back. We're going to see that. Then we're going to do fetch slow, wait 6 seconds. Then slow result is going to come back. So in total, we're waiting 2 seconds plus 6 seconds, which is 8 seconds. Okay, plus a few, I guess, milliseconds or less than a few milliseconds for the rest of the code to kind of get set up. So let's take a look at this. If we run node, exercise 2 in my case, .js, so we see program starting, program complete right away. Fast is done. We're going to wait 6 seconds, and then eventually slow is going to be done, right? So, you can see right here that my terminal says it's 8 seconds, but how would we actually be able to time this? So we can actually kind of use a trick with the date object. Now we're going to be using this in more detail in future videos, but just kind of for sake of example, I just want to show you really quick how this is going to work. I'll just first kind of log out a new date object, just like this, just so that you can actually see what that's going to be. I'm actually going to comment out my use data just so we don't have to wait for too long. And you can kind of see that we kind of get this timestamp right here. Okay, so if I do a console.log of a new date object again, and then I guess I kind of messed this up. What I want to do here now is I want to first time is equal to a new date. And then I want to console.log another call to date minus the first time. Okay, so I'm going to get a snapshot of date here, then I'm going to get another date here, and I'm going to subtract the first date that I got. So this seems kind of odd, right? But what you're going to see is we actually end up getting a number. Okay, and this is the number of milliseconds that has passed between us creating this date object here on line 40, and then creating another date object here on line 41, and subtracting kind of the first date object. Okay, so 0 milliseconds, not very helpful to us, right? Because this code runs so fast that we actually execute this code almost instantly. So we can actually use these date objects, create a date, create another date, and then subtract the first date to actually get kind of a good understanding. Generally speaking, it's a bit rough. There are kind of more granular ways to do this, but this is a pretty decent way kind of to get rough calculations of the amount of milliseconds that pass between the first timestamp and then the second timestamp. So let's use this concept. I'm actually going to, as soon as program starts, I'm going to say const first timestamp is equal to a new date. Okay, oops, wrong spot for the semicolon. And then I'm going to comment back in my use data. And then right before the end of our program, I'm going to say const second time. Let's make this really explicit. Second timestamp is equal to another new date. Okay. And I think I spelled this wrong, timestamp. And we're going to say const time elapsed, which is the time kind of that's gone between the first and the second timestamp, is going to be the second minus the first. Okay. And we can log out the time elapsed right here after our program complete. So most important is that this is happening at the very start of our program or before we want to kind of measure the code. And then this is happening after our use data call. And we want to kind of measure that code after. I actually realized that this is actually even buggy, and this shows you kind of how confusing asynchronous code is, because this is actually going to run right after. So we're actually going to see zeros printed out, which is not what we want. Just really proving to you how confusing this asynchronous code can get, even with async await. So technically what we want to do is actually take this code and put it down here. Want to kind of put that here, and I'm just going to take this and I'm going to put it here as well. So sorry for the jumping around here. Hopefully you can see that this definitely takes some time to really get used to, and even after using this for so long, I still get mixed up a lot of the time. But async await definitely helps a little bit with this. So I have to put this code inside here because our code outside here is actually going to run before our awaits complete, because our awaits are going to kind of pause this function. So we want to wait this amount of time, and then we want to log out our dates. So moment of truth, finally, let's see if we actually get this. So program starting, then we're going to get our fast done, then we're going to get our super slow done after 6 seconds, and then the timestamp, which is 8,003 milliseconds, which is about 8 seconds. Okay, so the milliseconds, again, not totally accurate, but gives you a good understanding. I mean, if you really want more accurate than milliseconds, you're probably doing something much more advanced, and there's different APIs to actually do that other than the date API. So that said, definitely use timestamps like this to get a good understanding of how long your code takes. I encourage you to write more async functions like this to actually get practice of logging it before and logging it after all your awaits, for example, just to see if that amount of time that's elapsed actually makes sense. Maybe you can do some logs in between here, for example, and see how long that's going to take, and really prove to yourself that the function is literally pausing, and it's going to not run this code over here until after that amount of time has actually elapsed. And again, really just to reiterate one more time, right now we're artificially doing this with set timeouts. In real life, we're going to do this with requests to remote servers or databases or things on our computer or other computers. And those are going to take different amount of time depending on kind of how busy the network is, or how busy the hard drive is, or all these other factors. And no two calls to those functions are ever going to be the same. Sometimes it's really fast, sometimes it's really slow, and sometimes it's even going to cause an error because something happened in between. So regarding errors, before we get to exercise 3, for practice, I'd like you to try kind of just putting errors in here and rejecting maybe one of these promises just for some extra practice, and seeing how you can surround some of this code in a try catch, which I didn't do in this case, just to speed up this video. Okay, so let's go to exercise 3. So this one is definitely a doozy, a lot going on here. So let's go through this slowly together to wrap up the video. We want to first create a function called goGetCandies, which is going to return a promise object that resolves to this value right here. This is going to return an object with 2 properties, one candy property and one quantity property, right? We're going to get 10 sour keys. This is going to take 2 seconds. Okay, so we're going to do a set timeout, 2 seconds to actually return this object. Then we want to create another function called sellCandies that's going to take an object that looks like this. So this structure, right, with a candy and quantity, and it's as an argument, and it's going to return a number that is 25 multiplied by the quantity in that object, kind of as if you were doing some kind of like stock or cashier calculation, right? So imagine it's a checkout, and we are buying 10 sour keys, and each sour key, for example, is like 25 cents. We would want to pay 25 times 10. Okay, this will be how much in cents that we get for our candies, and we want this function to take 3 seconds instead of happening instantly. So this is something that would normally happen instantly. We wouldn't need to artificially delay this, but we're simulating kind of what would happen if we were to kind of ask a server somewhere or ask some other computer somewhere on the internet to do this calculation for us. Maybe it's a very complex calculation and it's going to take some amount of time. It might be very fast, but it's not going to be 0 or 1 millisecond. Okay, so we basically want to return a promise with this number that's going to be 25 times the quantity after 3 seconds in a set timeout. Okay, as a promise. Then we want to create an async function that uses await to kind of do these things. We want to get the candy object from goGetCandies, right? Which is going to take 2 seconds. Then we want to pass it to sellCandies, and we want to wait for that response. So that's going to take 3 seconds. Then we want to print out how much money we made from our sale, or how much money we owe, I guess, depending on how you're thinking about it, from our sour key sale. Okay, and then we want to also do the same thing. And this is where it gets really, really tricky. This one line here is actually quite tricky with vanilla promises, right? To really compare the differences between kind of what async await allows us to do and how it simplifies a bit of our code and our mental model around promises versus vanilla promises. Okay, so let's take a look at this. I guess should let you try this yourself first, but I just realized I should probably ask you these questions as well. Which of these two, once you've done step 3 and step 4, sorry, do you prefer, right? Which is easier to read? Which kind of makes more sense? And is there maybe like any dangers that you might see with step 3 versus step 4? Okay, so give that a shot. Try to answer those as best you can, and even try to code this as best as you can. Definitely a very, very challenging one, and we'll take a look at it together. Okay, so let's start with creating a function, goGetCandies. So it's a regular function, goGetCandies, and this is going to return a promise object that resolves to this object right here. So return new promise. This is going to resolve. This is going to reject. And this is going to take 2 seconds, 2000 milliseconds. All right. And we want to resolve with this object. Okay. And I always mess this up. I put the 2000 in the wrong spot. Probably sick of me doing that by now. I'm going to do a set timeout. And this is the 2000 right here every single time. And we're going to put this up here just like that. All right, great. So now we have step 1 complete, so we can go to step 2. I'm just going to minimize this for now to give myself some more space. I'll create another function called sellCandies that's going to take this candy object and return a number that's 25 times the quantity. Okay, so I'm going to create const sellCandies. This is going to take a candy, and we're going to return 25 times the quantity. So we want to return 25 multiplied by the candy dot quantity. Okay, interesting. So the caveat here is that this math could be done synchronously, kind of could be done right away. However, we want it to be done after 3 seconds. So we want to kind of simulate a delay using a set timeout. So we're going to need to return a promise that resolves with this value, but after 3 seconds. Okay, so I'm actually going to change this a bit. I'm going to say return a new promise. This promise takes a resolve, takes a reject. Hopefully your fingers are used to typing this almost in your sleep at this point. And in here, we want to do a set timeout. And we want this set timeout to take 3,000 milliseconds. Okay, and we want to return 25 times the candy quantity. So I'm just going to grab that. And I'm going to say I want to resolve with that value after 3 seconds. So I'm going to do this math, 25 times candy.quantity. So if I get this candy, right, I'm going to look for candy.quantity, which is this pair right here, and I'm going to get the value 10. Okay, so I'm going to do 10 multiplied by 25, which is 250, and I'm going to resolve a 250 after 3,000 milliseconds. All right. Now that we have that, let's write step 3, which is where things get interesting, which is our async function. So I'm going to say const, let's say use candies. Async, this makes it much easier for me mentally to go with this pattern. Get the candy object from go get candies. Okay, so this is going to be a promise. Okay, we want to wait for this candy object. So we know in an async function, we can wait for it using await. So I'm going to say const candy is equal to awaiting go get candies. Okay. Then I'm going to pass candy to sell candies, which itself is also going to return a promise. Okay, so I'm going to sell candies with the candy object. Okay, and this is going to resolve with a value. So I want that value given to me. Okay, so I can actually await it. So I can say const, let's just say like result, I guess, in this case, and we can say await. This is going to be the kind of, number of cents that we're going to get from selling these candies. So in this case, we expect the result to be 250. So then I want console.log out. Oh my goodness. I want to console.log out result. Okay. Wow, a lot going on there. So we're going to wait 2 seconds for this. We're going to wait 3 seconds for this. And then we're going to kind of log out that result. So one thing to keep in mind here is that we are using await for these two things. And we are actually needing the result from the first await to actually call the second function. We can't call sell candies until we actually have a candy to give it to calculate the quantity for, right? So we would not be able to kind of do these in parallel. That actually makes me realize that I think I forgot something in exercise 2. So let me quickly switch back to that to show you the answer in case you were kind of like, oh my gosh, I hope he goes back to that to show us what's up with making this answer, number 8, actually work. So to speed this up, what we can actually do is run these in parallel, right? That was kind of the hint I gave at the start of this one. And this is kind of a good comparison to the one we're looking at right now. So in fetch fast and fetch slow, they don't actually rely on each other at all, right? Fetch slow doesn't care about fetch fast and fetch fast doesn't care about fetch slow. So we can technically run these in parallel. Right now we saw that it's taking 8 seconds, right? 2 for this and 6 for this. But if they don't really rely on each other, it's going to take the longer of the two. If we start them at the same time, one takes 2 and one takes 6, it's going to take 6 seconds in total if they can run at the same time. Okay, so that's not what's happening right now, right? Because we're actually waiting for fast to finish first, which is going to take 2 seconds. Then we're waiting for slow to finish second, which is going to take 6 seconds. So in order to actually speed this up, what we can do is realize that we don't actually need fetch fast first to actually do fetch slow. So we can actually leave these as not paused await values here, just as their regular promise results. And I can say const result is equal to, and we can use promise.all and we can pass it an array of vanilla promises that are going to all kind of resolve. And once they all resolve, we're going to get back a value which we can use in result. Okay, so I'm going to pass it the fast result, and it's going to give, we're going to pass it the slow result, which are both promises, right? These are both promises, and I'm going to actually await these being done in parallel together, which is what promise all does. Promise all will take those promises, start them off at the same time, and then wait for all of them to resolve and give us back the result. So if one takes 2 seconds, one takes 6 seconds in this case, we go kind of 2 seconds, and then this second one has 4 seconds left, and then we wait 4 more seconds. So we're actually going to, I'll put this up here just so we can show that that's a pending promise. Then we can console.log out the result. Okay, so just to show you this, we saw previously that it took 8 seconds. So I'm claiming now it's going to take 6 seconds. So let's see if that is actually true. So we see that there's 2 pending promises, which is what's happening on line 46 as well as on line 49. And in this case, you can see that just over 6 seconds, but definitely a big improvement over the 8 seconds that we saw previously when we were actually running them kind of synchronously, one after the other, okay, in sequence instead of in parallel. So very, very useful. And again, this only works if these two are totally independent and we don't need the result of fast result in order to do fetch slow or vice versa. So switching back to exercise 3, sorry for that tangent, that is not true here, right? Hopefully you can see the difference. Right here, we actually need candy before we can actually call sell candy. And this happens so often in real code in web development, right? Here we kind of got both the results back after 6 seconds because they're not related. But in this case, we can't do anything with sell candy unless we have a candy object, right? And the candy object that we're interested in is the one that's coming back from go get candies. So these have to be sequenced one after the other. And this is where await really, really, really shines, okay? Because we can say pause and do not do anything until you get candy. Then once you have candy, now we know we have candy for sure, and we can use it in the rest of the code on line 43 and below. Okay, so let's call this function and kind of see what happens. I've been yapping so much. Let's actually make this work. So I'm going to, did I say print out program complete? I'll just do that just so that you can see console.log program complete. And I'll put a program starting kind of right here as well. Program starting, just so we can kind of sequence these and see how they work. All right, so let's run this code. I'm going to run node exercise 3. So program starting, program complete, run right away, right? Because we're doing an await. And then eventually what we'll see is 5 seconds pass, which is the 2 seconds here, as well as a 3 seconds here, right? So to really kind of get that timed again, let's confirm kind of our suspicion. I'm going to say const, I'll just be really simple with the dates here, or I'll say like time1 is equal to new date. And then I'll say const time2 is equal to a new date. And then I'll say console.log, and I'll say, oops, time2 minus time1 milliseconds passed. Okay. So if we run this, what we'll see is 250 is a result, right, which is on line 45 or 44, sorry, and then 5,007 milliseconds passed by in the time that we actually ran our use candies function, right? And that makes sense because that's our 3 plus our 2 right here. Perfect. In this case, we cannot use promise all to accelerate this because, again, as I mentioned a few times already, it's required that we have candy before we do line 43. So we can't actually speed this function up. We're kind of at the mercy of this slow code right here. So lastly, I'd like to show you how we can do this, but with vanilla promises. So luckily we can actually do this without kind of too much effort. What I'll do is I'll just comment out use candies right here, and I'll say const candy is equal to go get candies. Okay, this is going to give us back a promise. Okay, we know with a promise we can do dot then. So I'm going to say candy dot then. Then I'm going to get a result. And then with that result, I know I need to call use candies, right? But use candies is also going to return, or sorry, not use candies. I need to call sell candies, but sell candies is also going to return a promise. So this is where things kind of get interesting. So I'm going to say const sell value, for example, or what did I call it here? Result. I'll call with no, I already used result. I'll go with sell value here, so it's just a bit more clear. You can see that we need more variables when we're actually using this syntax. So we're going to say sell value is equal to calling our sell candies, and we're going to pass sell candies our result from our first one. So yeah, I guess the extra variable here we have is this initial candy right here. We kind of have to have this intermediary value of result. So now this is also going to be a promise, right? We're going to get back a promise from sell candies. So this is not actually going to give us the value. So you'll see that if I console.log out sell value, what's going to happen is after 2 seconds, we're just going to see a pending promise. So let me run this. We're going to see a pending promise, right? It's still going to take that 3 seconds for sell candies, but we're not going to get that result because we're not actually dot thenning it. So what we want to do is we want to say sell value dot then, and then we're going to get back the value. And now we want to console.log out that value. Now this is getting really hairy, and this is the purpose of why I wanted to show this to you, because there's a lot going on here, and this is much harder to reason about than our previous async await example. So pending promise, then 3 seconds are going to go by, and then our 250 is going to come back, which is on line 59. Okay, so what's happening is we're getting a promise that's pending. We're going to do dot then. This is going to happen after 2 seconds, but we're going to call sell candies. That's going to be pending promise. Then this here is going to happen after 3 seconds. Okay, this console log. So we're going to have 2 seconds plus 3 seconds, which is going to be 5 seconds. So if I do the same thing here, where I kind of copy these two, where I create a new time just to save us some time, and I put it in here, where I create a second timestamp and then log it out, what we'll see is the same amount of time passes, which is going to be about 5 seconds in total, but we're just using the dot then in this case. Okay, so 5,006 milliseconds has passed. So hopefully you can see, right? This is the two pieces of code that we're comparing. We're comparing this to this. Okay. Now, in my opinion, I would much rather deal with this code, right? It just is easier to reason about. I can see, okay, I'm waiting for candy, then I'm selling the candy, I'm waiting for the result, then I'm logging it out, right? This is just, it's a bit crazy, right? There's quite a bit going on. It's like, okay, I got a candy. Like, what is this thing? Okay, it's a promise. Okay, I see dot then. And then it's like, okay, but then like this sell candies, is that going to happen right away? No. Okay, that's a promise too. Okay, then another dot then. But then like, am I still in the first dot then? Or like what is happening, right? So you can imagine that if we're kind of creating imagine if we had another a thing that was reliant on result, like something here, like we had to use the result, for example, right? And then that was a promise as well. We had another await, right? Then we would have to nest another dot then in here. And this is kind of what's called like the callback hell or promise chaining hell, where we have just so much of this code getting indented, and we kind of lose track of like which promise starts where, which promise ends where, and how do we deal with errors in this case? What happens if this one causes an error, or then this one causes an error, and things kind of just get totally crazy very quickly, even just with 2 or 3 of these things going at once. So hopefully, you can see that async await really helps simplify this, and this is why it was added to the language. However, there's definitely a lot that we need to know so that behind the scenes we don't accidentally add time to our functions like we did over here, right? If you know how async await works behind the scenes, you can do things like this where you can make it work just as fast. If you can use things like promise all, if you don't need them to be sequenced, but then if you do need them to be sequenced, you can very, very easily write very concise, easy to read, top to bottom code using the async await syntax, where the promise.then syntax would get totally out of hand and probably even cause errors or bugs because of just trying to figure out what goes where. So I know that was a long video. I really, really love async await and I love promises. I wanted to spend a bit more time going through this concept with you. I hope that you found this exercise video valuable. If you did, please like the video and subscribe to the channel. I'd love to hear in the comments kind of what you think of these exercises, specifically with this async await. Were they hard for you? Were they easy? Did you run into these problems yourself as you were trying to code your own projects or code your own examples? Or did you just run into any issues as you were trying to go through these yourself? And again, I apologize for jumping around a little bit, but hopefully kind of that comparison at the end did help a little bit. So with that said, what we're going to do is in the next video, we're actually going to go over kind of a new piece of syntax in JavaScript called the spread operator, or the spread syntax. And this is going to allow us to kind of work with copying things like arrays and objects and other things a little bit easier. It's a newer piece of syntax added to the language, and it just comes up all the time on things like front-end development and even back-end development. So it's definitely worthwhile to create a video just for that and its own series of exercises. So I can't wait to get to that video. I hope these exercises were useful for you. I'll see you in the spread syntax video.